To characterise the impact climate change will have on a project, it is important to analyse the risk considering future climate scenarios, in addition to the risk analysis considering current weather conditions. In this video, we will introduce the key aspects for the analysis of future scenarios. In this regard, we will see what scenarios should be considered in infrastructure projects, and how the results obtained from an investment alternatives approach influence the risk reduction. One of the main challenges of assessing climate change impacts at the local level is that it will increase the uncertainty of modelling. On the one hand, we have the uncertainty of the possible concentration of greenhouse gases in the atmosphere. We currently have X possible representative concentration pathways, ranging from the most optimistic to the most pessimistic. On the other hand, we have a large number of general circulation models that allow us to model the climate given a specific concentration scenario. It is therefore a complex exercise. However, that should not discourage us. There are various techniques to incorporate climate change, depending on the data and the resources available. The most important thing is to integrate climate change and the uncertainty it generates in the investment decision at the local level. Countries, as part of their communication reports to the United Nations Convention on Climate Change, have generated climate change projections, and these values are an important reference for the design of our investments. There are websites where we can download integrated information from various general circulation models for different concentrations. A conservative approach would be to use the most unfavourable values of CPR 8.5. If we had more resource and time, perhaps for larger investment projects, we could perform a statistical downscaling of general circulation models using local rainfall data. What we would do would be to use the observed patterns of the current climate to refine the general model of the global circulation model. And finally, we could use supercomputers and make simulations with daily weather prediction models for the next few years. This is what is known as dynamic downscaling. Then again, it is important to keep in mind that the impact of climate change uncertainty increases with the time horizon of the analysis, and that in addition to the climate change, there are other sources of uncertainty, such as population growth. Other than modelling what could happen, we can also design more resilient measures against climate change by adopting a low-regret approach, where we try to plan measures that will respond to different future scenarios. The low-regret approach attempts to prevent a measure from reducing the current risk, but not counteracting the effects of climate change, which in the long term would lead to a greater risk than the initial one. For example, we have a city, A, that is flooded by a river and the sea. To protect the city from the river, we build a wall, and then we build another wall to protect the city from the sea. As the walls make the drainage difficult, the city begins to flood by direct rain. Then we install pumps to pump the water out. As there is more sense of safety, many homes are built near the walls, and so the exposure increases. In 20 years, we have more exposed population. And when there is an exceptional event of rain, the walls are overcome and a disaster occurs, much bigger than the one we wanted to avoid. Perhaps an approach with a well-planned land use would have been better, where the river would have had more space to flood safely, construction would have been made with materials that enable infiltration, and better management of the basin would have been done. This is the low-regret approach, which is based on the search for global solutions and the use of sustainable and green infrastructure. In summary, it is important to include the analysis of the impact of climate change to determine the risk reduction measures and investments to be made in infrastructure projects in a changing and dynamic context.